Let's take our minds back to February of last year, a moment etched into the history of space exploration. The entire world held its breath as NASA accomplished what seemed nearly impossible, landing the Perseverance rover safely on the dusty surface of Mars. The excitement and global fascination were overwhelming. In the footage we saw a sprawling crater, once a vast lake nearly 3.2 billion years ago. That image alone offered something truly extraordinary, a direct, almost magical window into the ancient history of the red planet. We weren't just looking at rocks and dust. We were peering into a moment frozen in time, into a world that existed eons before human civilization began. This crater is like a Martian time capsule, preserving secrets of a past that scientists are now working to decode. Since its successful landing, Perseverance has exceeded expectations. Equipped with state-of-the-art instruments and next-generation cameras, it has been sending back images that are nothing short of breathtaking. These aren't just standard photographs, they're high-definition 4K visuals, giving us an ultra-clear and immersive experience of Mars' rugged and alien terrain. It's one thing to imagine another planet, it's entirely different to see it with your own eyes in such incredible detail. These visuals offer a real sense of place, transporting us into a landscape that, not long ago, existed only in sci-fi dreams. The continuity of exploration is also a powerful story here. Perseverance builds upon the path carved by the Curiosity rover, which was also known for capturing stunning 4K images of Mars. These captivating photos aren't just for show. NASA's billion-dollar investment in these missions has a much more profound purpose. The images serve as key scientific tools, revealing geological formations, erosion patterns, mineral deposits, and potential signs of water, all of which help build a clearer picture of Mars' past environment. To truly grasp the value of these images, it helps to look back at the broader history of Mars exploration. Over the last 2 decades, NASA has launched several groundbreaking rovers to the red planet. Each new mission has added another layer of insight, pushing the limits of what we know and what we can dream of knowing. These missions aren't isolated, they're chapters in a continuous story of discovery. In 2003, NASA introduced the world to Spirit and Opportunity, twin rovers tasked with hunting for signs of ancient water activity. They weren't just robotic explorers, they were scientific pioneers. Their discoveries transformed what we thought we knew about Mars. They uncovered strong evidence that Mars once had conditions suitable for sustaining life. Imagine the excitement of finding out that a planet once thought of as a frozen, lifeless desert might have once been warm, wet, and potentially alive. These findings gave a whole new level of importance to Mars exploration. Then in 2012 the Curiosity rover landed in Gale Crater. This mission changed the game. Curiosity wasn't just there to snap pictures. It was equipped with advanced tools for conducting planetary science on-site. Curiosity's journey began with a dramatic launch from Cape Canaveral on November 26, 2011. It then traveled over 560 million kilometers, or about 350 million miles, through the vacuum of space. After a suspenseful descent, it landed on August 6, 2012, in a flat region of Gale Crater known as Aeolis Palus, near the base of a towering 5.5-kilometer mountain called Mount Sharp. The goal of the mission was both ambitious and precise: to explore Mars' climate and geology and determine whether the planet had ever supported life. Scientists specifically chose Gale Crater because of its rich geological diversity and evidence that liquid water once flowed there, making it a gold mine for anyone studying ancient habitability on Mars. Curiosity set out to do something no rover had done before: analyze the Martian soil, rock, and atmosphere for key elements that are essential to life as we know it. It searched for carbon, hydrogen, nitrogen, oxygen, phosphorus, and sulfur, all of which are considered biological building blocks. The presence of these elements could hint that Mars once hosted, or may still host, microbial life. Curiosity also looked for what scientists call biosignatures, chemical markers that suggest the presence of life, even if that life is long gone. In addition, the rover was equipped with an innovative instrument called the ChemCam. This device uses a powerful laser to vaporize rock surfaces. The resulting plasma is then analyzed to determine its chemical makeup, offering clues about the planet's geological evolution. The data gathered by Curiosity revealed that Mars had a dynamic history involving water and volcanic activity. These findings helped reconstruct how the planet changed over billions of years. Importantly, Curiosity also studied the current Martian atmosphere, with a special focus on water vapor and carbon dioxide cycles. Understanding these cycles helps scientists trace the evolution of Mars' climate and determine how it shifted from a possibly warm and wet world to the cold, dry planet we see today. This kind of knowledge isn't just academic, It could directly influence future attempts to terraform Mars or make it hospitable for human life. If we understand how the planet lost its water and atmosphere, maybe we can figure out how to restore them. Another crucial aspect of Curiosity's mission was radiation measurement. The rover constantly monitored various forms of radiation hitting the Martian surface, including galactic cosmic rays, solar proton events, and secondary neutrons. These measurements are essential because any long-term human mission to Mars will need to address the radiation risks posed to astronauts. Mars doesn't have a strong magnetic field or thick atmosphere to shield against these particles, making radiation a serious challenge. By collecting this data, Curiosity laid the groundwork for designing safer habitats and suits for future explorers. Every bit of information adds to the dream of humans walking on Mars one day, and doing so safely. In 2013, just a year after it landed, Curiosity made a groundbreaking discovery. It found evidence of an ancient streambed inside Gale Crater. Smooth, rounded pebbles scattered across the Martian surface suggested that flowing water had once shaped this landscape. These weren't random rocks, they were geological storytellers. Along with the detection of clay minerals, which form only in the presence of water, these findings added yet another layer of confirmation that Mars was once capable of supporting life. These discoveries sparked new excitement and bolstered the scientific community's belief that we might eventually find direct signs of microbial life, either past or possibly even present, hidden beneath the Martian soil. Curiosity also turned its cameras to the sky, or rather back to Earth. Through its advanced imaging systems like the Mastcam, it captured high-resolution photographs that have become iconic in the world of planetary science. These images reshaped how we view Mars, not just as a cold red rock, but as a world of mountains, valleys, sand dunes, and layered sedimentary rocks. They revealed the raw beauty and alien complexity of a planet that once had rivers, lakes, and perhaps even a more Earth-like climate. These visual insights gave scientists more data than ever before and ignited the imagination of millions around the globe. In February 2021, the Perseverance rover continued this journey and launched us into a new chapter of Mars exploration. On March 4, 2021, just weeks after landing, it conducted its first test drive, leaving fresh wheel tracks in the Martian dust. But Perseverance wasn't just there to roam around, it had a bolder mission. It began collecting and caching surface samples, including Martian soil, rock fragments, and atmospheric particles. These are the first samples that NASA intends to bring back to Earth through the Mars Sample Return mission. The opportunity to study these materials in Earth-based laboratories could answer some of the most fundamental questions we have about life beyond our planet. Among Perseverance's early findings was a Martian rock bearing strange, leopard-like spot patterns. These markings could be clues pointing to complex geological or even potential biological activity in Mars' distant past. But Perseverance isn't just about science, it's also a symbol of hope and unity. Before launch, NASA invited the public to submit their names to be sent to Mars. Over 10 million people responded. Those names were etched onto microchips and placed aboard the rover, turning it into a collective human ambassador, representing not just American space efforts but the curiosity of an entire planet. During the global COVID-19 pandemic, NASA also took a moment to honor frontline healthcare workers. A commemorative plate was affixed to Perseverance in their tribute, reminding us that even in difficult times on Earth, we can look to the stars for hope and inspiration. One of the most inspiring hidden details was found in the parachute that slowed the rover's descent. Engineers encoded a message into the parachute's orange and white pattern: "Dare mighty things." This phrase has since become an emblem of NASA's bold spirit, a call to challenge the impossible. The rover didn't disappoint in delivering stunning visuals. One of the first was the Octavia E. Butler landing image, taken in February 2021. It captured the exact moment Perseverance touched down, with a smoke plume still rising from its descent stage. The rear right hazard avoidance camera captured the rugged Martian landscape, helping engineers navigate the harsh terrain. On Sol 213, a remarkable image showed Perseverance's parachute and back shell resting on a distant ridge, about 2 kilometers from the rover's location. These images aren't just beautiful, they're data-rich snapshots of engineering success. Perseverance's first color image gave us a vivid look at the reddish Martian surface, highlighting the scattered rocks and fine dust. Later, a panoramic shot from Sol 14 offered a sweeping view of the terrain after the rover completed its first long drive. From orbit, the Mars Reconnaissance Orbiter captured an aerial image of the rover, and Perseverance responded in kind, photographing the tiny Ingenuity helicopter on the ground nearby. These mutual captures created a powerful visual connection between two machines working together on another world. Then came a historic moment that no one will forget. In April 2021, at a spot on Mars named Wright Brothers Field, the Ingenuity helicopter performed the first powered, controlled flight on another planet. That small liftoff was a giant leap for aerospace history. Later, the Vanzel Overlook image delivered a breathtaking panoramic view of Mars' rolling hills and dusty plains. Ingenuity also captured video and audio of its flights, including one in April and another during its 11th flight in August 2021, which provided an aerial view of Perseverance from above. These achievements aren't just milestones in science. They're a tribute to human ambition, innovation, and the relentless drive to explore the unknown. Through every frame, every sample, and every flight, NASA is reshaping our understanding of Mars. These missions aren't just about robots, they're about us, our future, and the incredible places our curiosity can take us. With every daring move, NASA continues to live by its motto, "Dare mighty things." As the Perseverance mission pushed forward, its groundbreaking achievements started to feel less like distant space milestones and more like tangible steps toward humanity's future among the stars. Every soil sample it drilled, every rock it analyzed, and every snapshot it sent back to Earth wasn't just a piece of Martian history, it was a glimpse into what could eventually become humanity's second home. Scientists around the globe worked tirelessly to decode these fragments of Mars, piecing together a timeline of the planet's history, trying to understand how it transitioned from a potentially life-sustaining world to the cold desert we see today. The mystery deepened with every new image of sedimentary layers and mineral-rich rocks, suggesting water once flowed freely here for millions of years, enough time perhaps for life to emerge. One of Perseverance's most critical scientific objectives has been its search for biosignatures, chemical or structural indicators of past microbial life. By drilling into ancient rocks that may have once been lakebeds or riverbanks, the rover aims to uncover preserved organic compounds. The discovery of such compounds could potentially confirm that Mars once harbored life, a revelation that would revolutionize our understanding of biology, evolution, and the uniqueness of life on Earth. These samples, once collected, are carefully sealed and cached in titanium tubes, designed to withstand the harsh Martian environment until a future retrieval mission arrives. The thought that one day these samples might be launched back to Earth, studied under powerful microscopes, and possibly reveal alien life is both thrilling and humbling. Meanwhile, the tiny helicopter Ingenuity, initially designed as a short technology demonstration, quickly became one of NASA's most surprising success stories. Originally intended for just 5 flights, Ingenuity exceeded expectations by continuing to operate for dozens of missions. Each flight provided critical data on flight dynamics in the thin Martian atmosphere, where air density is less than 1% of Earth's. Its rotors had to spin incredibly fast, about 2,400 RPM, to generate enough lift. But more than just proving that flight was possible, Ingenuity became an aerial scout, surveying terrain, helping Perseverance plan safer and more efficient routes, and capturing stunning aerial images from angles never seen before. This partnership between rover and drone marked a new era in planetary exploration, one where robotic teamwork expands the horizon of discovery. While Perseverance and Ingenuity carry out their historic tasks, Mars remains a planet of contrasts. Its serene red plains hide violent volcanic pasts. Its dry riverbeds whisper tales of ancient floods. Massive dust storms can engulf the planet for weeks, and temperatures can swing from mild to freezing in just hours. And yet, amid these harsh conditions, both machines continue to function day after day, enduring, analyzing, and transmitting vast amounts of data back to Earth. Each dataset adds another page to the Martian story, slowly unraveling secrets buried under billions of years of history. It's not just the quest to understand Mars, it's the pursuit of understanding how planets evolve, how climates change, and perhaps even how life begins and ends. What makes these missions even more powerful is the way they connect with people. NASA's choice to include over 10 million names aboard Perseverance wasn't just symbolic, it was deeply emotional. For many, it meant being part of something much greater than themselves. Children, teachers, engineers, and space dreamers from every corner of the world found a piece of their hope etched into that rover, now resting on a planet millions of kilometers away. It turned an elite scientific mission into a collective human journey. During the dark times of the COVID-19 pandemic, Perseverance stood as a beacon of progress, resilience, and unity. The tribute plate honoring healthcare workers was a powerful reminder that science and compassion often travel hand in hand. The famous coated parachute from Perseverance's landing bearing the phrase, "Dare mighty things," became more than just a clever engineering Easter egg. It became a rallying cry. Engineers and mission planners adopted it as a badge of courage, and space enthusiasts around the world embraced it as a reminder of what's possible when humanity dares to dream big. This phrase, originally from President Theodore Roosevelt, now echoes across classrooms, laboratories, and social media posts. It captures the essence of space exploration, the willingness to take risks, to embrace the unknown, and to relentlessly chase answers to the universe's biggest questions. In many ways, the images sent back from Mars transcend their scientific value. They are art, emotion, and evidence of possibility. The shot of Perseverance during its descent, with the sky crane above and Martian dust billowing below, feels more like a science fiction scene than a real event. The panoramic views reveal hauntingly beautiful landscapes, craters with jagged rims, windswept dunes, and distant hills bathed in soft orange light. Each photo reminds us that despite the alien nature of Mars, there's something oddly familiar about it too. Perhaps it's the Earth-like valleys, or the mountain shadows at dusk, or the sky turning slightly blue during twilight. These glimpses strike a chord deep within us, suggesting that the red planet might not be as distant as we once thought. Another major highlight of the Perseverance mission is its focus on preparing for human exploration. For the first time, a mission is actively gathering information needed to send astronauts safely to Mars. One of the tools helping in this regard is MOXIE, the Mars Oxygen In Situ Resource Utilization Experiment. MOXIE successfully extracted oxygen from the planet's carbon dioxide-rich atmosphere, a major milestone for future manned missions. Producing oxygen on Mars could support breathing for astronauts and serve as oxidizer for rocket fuel, making return trips more feasible and cost-effective. This tiny box aboard the rover has opened a door to a self-sustaining future on Mars, where astronauts might one day live off the land instead of relying entirely on Earth-supplied resources. Beyond oxygen production, Perseverance is testing new navigation and landing systems, crucial for upcoming crewed missions. Its terrain-relative navigation system allowed for a pinpoint landing in a narrow, scientifically interesting area, something essential for human landings. Future Mars missions will need to land near specific resources like water, ice, or natural shelter. The success of this landing system means astronauts will have greater flexibility and safety when choosing landing sites. By perfecting these technologies robotically first, NASA is laying the groundwork for the first human footprints on another planet. The mission has also underscored the importance of international collaboration. Perseverance's instruments are the result of partnerships between NASA and institutions across the world. The Sherlock instrument, for instance, uses spectrometers and lasers to analyze surface minerals, and it carries materials that might one day be used in astronaut spacesuits. Meanwhile, the SuperCam, developed in part by French space agency NIS, combines laser-induced breakdown spectroscopy with other tools to identify rock composition from a distance. These international efforts reflect a growing trend in space exploration: global unity in the pursuit of knowledge. As we push farther into the cosmos, such collaboration will become even more vital. The anticipation surrounding the Mars Sample Return (MSR) mission adds another layer of excitement. If all goes as planned, a future mission will retrieve the sealed samples Perseverance is collecting and bring them back to Earth in the early 2030s. Scientists hope to conduct advanced chemical, isotopic, and molecular analyses that are impossible to perform on Mars. These samples could answer critical questions. Did Mars ever harbor microbial life? What was its climate like in the ancient past? Could it be habitable again in the future? The MSR mission is considered one of the most ambitious and scientifically valuable undertakings in planetary science history. Meanwhile, the world watches as Perseverance continues its trek across the Jezero crater, a site once believed to be home to a vast river delta and lake system. This location was carefully chosen because it may offer the highest chance of preserving ancient life. The sediment layers here could hold trapped organics or fossil-like structures. As the rover carefully climbs over rocky terrain and drills into ancient formations, each new day brings the potential for a discovery that could change history. Even the smallest anomaly in a rock formation or chemical trace could signal life's past presence. Even today, the mission continues to unfold. New images, new discoveries, and new experiments are released almost weekly, keeping scientists and the public alike on edge with anticipation. The path Perseverance is paving isn't just about finding signs of Martian life, it's about redefining what's possible. The mission is about innovation, endurance, and above all, hope. It reminds us that exploration is a fundamental part of the human spirit, something we've carried since we first gazed at the stars. And as perseverance moves forward, both literally and figuratively, it carries with it more than just instruments and experiments. It carries our dreams, our questions, and our collective belief that even in the vast emptiness of space, we can find meaning, purpose, and maybe even our future. From a dusty red world millions of kilometers away, this six-wheeled scientist continues to echo a powerful message back to Earth, that the unknown is not to be feared but explored. Through the lens of its cameras and the data it sends, we are reminded that the universe is not a silent void, it is a place full of stories waiting to be told. And as we decode the secrets of Mars, one rock and one flight at a time, we find that perhaps the greatest discovery isn't just out there on another planet, it's within ourselves in our endless drive to explore, learn, and dare mighty things.